Imagine that after writing a software feature, one of your colleagues couldn't fix a minor error that occurred within your source code. You see, this issue occurs frequently for many developers. So, what steps can be taken to ensure your software is flexible, maintainable, and readable? Solid principles. This stands for a set of 5 design guidelines for creating code that is easier to maintain. Over the years, these principles have completely transformed how we use object-oriented programming, changing the way we write code. Let's begin with the first letter of the acronym S, which stands for the Single Responsibility Principle. We can consider single responsibility in the context of something as common as vehicle gear. A vehicle gear serves only one purpose: to change the speed at which it moves. Single responsibility implies that a class should only be responsible for one thing, meaning that a class should only change for one reason. Consider a simple implementation of a gear class for a car. This class is tasked with 2 things: changing the gear level and accelerating. In reality, a gear is intended to perform a single function, which this class does not. Let us use the single responsibility principle to improve this class. This is how it looks. We created a new class called gas pedal, which is in charge of car acceleration. As a result, the gear class can concentrate on the desired functionality. If you can think of more than one reason to change a class, it probably has several responsibilities. The class in the previous example was performing 2 unrelated functions. If any changes are made to a function in the future, the gear class would need to be changed, posing a significant risk to the entire system. As a result, it is crucial to understand and apply this principle correctly. Let's look at 3 use cases of single responsibility. The first is data persistence. As a software engineer, you frequently implement data caching within a system. It is best practice to separate the function to improve usability. Another aspect to consider is validation. In most cases, you will validate user input within your system. Having a class for this purpose allows you to avoid having to rewrite code every time a new layer of validation is required. Logging is another use case. The mode of debugging will most likely change once the software is in production. As a result, to manage errors resulting from user interactions and system behaviors, a single logging class is required. The use of single responsibility simplifies, condenses, and maintains your code. If you apply this principle, a class change would have a relatively small impact on the overall software in the future.